If you're new to the channel, welcome. And if you're a returning viewer, welcome back. And thanks for tuning in again. I've got an exciting topic to cover in this video today. I'll be walking you through how I developed a RAG application using an open source model. Now, there is a slight quirk to this because that open source model I have actually fine-tuned to respond to queries like Master Yoda from Star Wars. On the surface, this might seem like a niche and quirky application, but I assure you, building this application revealed a lot of different engineering tips that may be useful for you when you're developing your own fine-tuned RAG applications. I would implore you to stay tuned to learn what those are, and hopefully you will discover some new things that you can take into your own engineering work. This video is sponsored by Gradient. Gradient are providing the platform for fine-tuning and running inference over the open source large language model that is used in the RAG pipeline. Gradient's a useful platform for anybody looking to fine-tune or use open source large language models within their own applications. They have integrations with things like Llama Index, LangChain, and Haystack, among others. They also provide a test environment where you can test your models to see if they're responding in the way that you wish. I'll be getting into more details about the Gradient platform and how you can use it to fine-tune your own models throughout this video. From a technical perspective, there are several aspects to this application that we'll cover in this video. So as I mentioned, we'll be looking at the Gradient platform in detail and how to fine-tune large language models using Gradient's Python SDK. I have some scripts that I will talk through. One of them is the fine-tuning script. The other script is a chat script where I have built the RAG pipeline in Llama Index, and I've put a chainlet front end for a slick UI on top of the RAG pipeline. I won't be going into the details of the RAG pipeline in this video, just to keep the video as short as possible and keep things manageable. I will, however, deliver this in a separate video that will be related to this. I'll be covering in some detail how Gradient uses parameter-efficient fine-tuning methods to make sure that fine-tuning on their platform is not only efficient, but cost-effective for you. So stay tuned to discover all of these tips, and hopefully this will help you progress in your own AI engineering journey. If you find this content useful and informative, please like the video, comment, share, and subscribe to the channel to receive more content like this. Thanks for tuning in, and let's get into the technical details. The model of choice will be the News Hermes 13 billion parameter model, and that model has been fine-tuned on the Llama 2 model to follow instructions. Let's talk a little bit about open source models. I want you to pay attention to the LinkedIn post I have on screen from Clem DeLange, who is the CEO and co-founder of Hugging Face. And for those of you that don't know, Hugging Face is one of the largest platforms for providing access to open source large language models and other generative AI and machine learning models. So Clem says, could we stop comparing raw models, Llama, Stable Diffusion, etc., with APIs, the likes of GPT-4, Claude? Most APIs probably include a lot of engineering tricks and even several models under the hood chained together or MO'd together. MO'd, I think here is just mixture of experted together. So these are not the same things at all and can't be compared. The reason I've brought this up is because those of you that are watching this video that are used to developing RAG applications with just the OpenAI API, making a call to that, you won't have had to do a lot of the engineering tricks behind the scenes to get these applications to work in the way you want. And this is something that is really important when you're using open source large language models. When we talk about fine-tuning large language models, you can think of the analogy as the raw large language model that you pull from Hugging Face or you pull from something like Gradient is like crude oil. It's not going to be immediately useful for your application necessarily. It needs some kind of refinement to be useful. And that refining process could be in the form of fine-tuning, or it could be in the form of adding an additional functionality to it, such as RAG. Either way, we're going to have to do some work to get the model to behave in the way that we want it to behave. Now, saying that, what you do learn doing this is the intricacies of large language models and how they really work under the hood. Because behind everything, beneath everything, we're dealing with really good next word predictors. And if you've tried to use an open source model before and it's just returned gibberish to you, that's probably why, because you're just dealing with it in its raw format and you haven't tuned it yet to do the task that you want it to do. So hopefully by progressing with me in this video, you'll learn some tips and hints that you probably wouldn't have picked up before, or that you might not have been aware of, to help you build with open source models. Right, so let's explore the Gradient platform itself a little bit at a really high level. What's good about Gradient is when you step in, you're presented with a workspace. And let's step into my workspace to see what's going on here. So within your workspace, you get access to the models that you have previously fine-tuned. So you can see 2 models that I've fine-tuned here for this Yoda RAG application. Gradient also provide a UI to fine-tune your models. So if you're not comfortable working in Python, you can do the stuff I will show you in the Python SDK via the UI. And that's simply done by stepping into the fine-tune tab and going to create a fine-tune model. And from here, you just follow the wizard to fine-tune your model. There is also a testing environment, which is really slick because you don't have to do anything. All you have to do is select your model from here that you fine-tuned, and you can also test on the base models to see how well your fine-tuned model performs for your task. Obviously, this isn't connected to RAG, and that is why I have built a separate Chainlit application to test the RAG model itself. So I've used this platform quite heavily and quite experimentally in building this RAG app. I've had to do several iterations of fine-tuned models and had to start again. And you can see with the token count I've used here that it is quite substantial for some of the models and also for generating the embeddings for the RAG application. And what I like about Gradient is even with all of that, it still was quite affordable. And if I step into the invoices here, you can see that I've only actually spent around $5.87. And in total, that was $10.87. But Gradient actually provides you $5 worth of free credits. All right, so it's time to step into some of the Python code. As I mentioned, I built this Yoda RAG application. And as part of that, I fine-tuned one of the large language models available from the Gradient platform. Let's have a look at this fine-tuning script to see how this works. I did mention previously that you can fine-tune the model using the UI offered to you by Gradient on their platform. However, they do also offer a Python SDK, and I prefer to use that because of the flexibility that it offers. Okay, so let's have a look at the code and how that's working. So at the top of the script here, I'm setting my environment variables. Obviously, to use Gradient, you'll need to sign up for the service, and they'll provide you with an API key to access the service as well as a Workspace ID. There's a separate file here, and the setup just literally pulls those keys in and sets them as environment variables to be used later on in the script. The other thing here is I'm setting all of my fine-tuning parameters at the top here. So things like the rank, the number of epochs, learning rate are all parameters for actually fine-tuning. And things like max retries, model name, and data are variables that are needed to let the fine-tuning script run itself. But I'll get into those in more detail as I step through the script. So the first thing is to actually read the data samples. So these data samples need to be in the form of a JSON lines file. If you're not familiar with a JSON lines file, I will pull one up on screen now. So this is what a JSON lines file actually looks like. And this is the file I used to actually fine-tune the model to sound like Yoda. And I'll get into how I got these examples in a second, but just take a look. So if you're not familiar, a JSON lines file is simply it's similar to a JSON file, but every observation or every line is actually just a JSON object or a JSON dictionary. So you can see that here, right? So that is one dictionary with the inputs, and then we have another one in the next line, and so on and so forth. And every dictionary corresponds to one observation. Now, there is something special about the way these dictionaries are constructed, and this is kind of, I guess, your first tip that you should pay attention to when it comes to fine-tuning models. And I'll talk about that next. And that is to do with templating and prompt templates. So before moving on to the prompt template point, just to give you an idea, this function here is used to actually read in that JSON lines file and create batches for fine-tuning. And the reason we need to create batches is because Gradient's platform, the version I have, I think the enterprise version might let you do more, but the version I have can only take 100 observations at a time. So if you have more than that, you can fine tune on that, but you'll need to break it up into batches of maximum 100 observations. Okay, So let's go back to the JSON lines file briefly, and let's talk about prompt templates. So you might have noticed that this JSON lines file is actually structured in a particular way. And if you can't see it now, I'm going to bring something on screen that will make it easier for you to see. Now, hopefully you can see what I have on screen now, which is the documentation for Gradient. And specifically, this is under their tips and tricks section, and it's to do with how we fine tune these models. The model I'm using is the News Hermes 2 model, which is based on Llama 2 that has been fine-tuned on an instruction dataset in order to allow it to follow instructions better. When you're working with such a model that has been kind of fine-tuned already, so you have the Llama 2 model, which is the raw model, and the researchers have taken it and fine-tuned it on instructions to make it work better. We call that instruction tuned. Now, what's interesting about what you need to pay attention to when you're working with instruction-tuned datasets is they come with something called a prompt template or prompt format, right? And something that will give you a big headache is if you ignore that prompt format and you just try to run inference on those models without following the prompt format or the prompt template, or you try to fine-tune them without following the prompt template. What's going to happen is the models might actually produce some gibberish. They might not perform the way that you expect them to perform. And I gather that some of you, if you've tried to play around with large language models before, you might have run into this issue. Sometimes you might ask the model to generate some text and it just seems to be kind of repeating itself, or it generates something that isn't related to what you've asked, or it generates, you ask it a question and it generates an entire conversation. That's usually because you're using the model in such a way that it doesn't follow the prompt template. So what I have on screen is the format in which you need to provide the examples for fine-tuning when you're working with the News Hermes 2 model from Gradient. And this follows the same format that the researchers actually provide. And if I step into Hugging Face, I'll show you that. So this is the model card on Hugging Face for the News Hermes 2 model. And if I step down, you can see the prompts format there, and it's exactly the same as what they have recommended on the Gradient platform. So you have the instruction there and your prompt, and then you have some spaces, and then you have the response. And that is where the model has been trained to fill or to generate its tokens, okay? Now, it is really crucial that you do not deviate from this format. And if you do, unfortunately, you will pay the price for that. You will be spending hours debugging and trying to figure out why your model isn't generating text like you should. There is also an alternative format, and you can use this format for inference as well. And this is where there is some additional context. So you'll see when we do the RAG component, you'll see that this is the format I've used to perform that inference. Right, so let's step back into Gradient under the tips and tricks. And as you can see, this is the general form for that format. And you have your input here, you have your instruction, you have your user message, and the user message will be some kind of instruction like, can you tell me how tall the Empire State Building is, for example, and then the response is generated by the model. When you're fine-tuning, you are providing both the instruction and the response. So now it's worth me moving on to explain how I got those examples in the JSON lines file for the Master Yoda RAG app. So I'll do that next. Coming up with samples for Master Yoda, and when we say samples here, I'm talking about actual speech samples, wasn't easy. And I should have really known this because actually Yoda is a alien of few words, let's say. So the thing I found was actually on Kaggle. I managed to find a Yoda speech corpus, and looking through this, it does actually have some examples of Master Yoda from the Star Wars movies. And you can see this kind of intermittently in speech exchanges with people like Mace Windu and so on. The issue here is that there just are not enough examples here. There's less than 300 examples. And, that's generous given that there's other characters here talking. So breaking that out into a sample file to fine-tune a large language model isn't really practical. The way I actually ended up getting around this was to ask ChatGPT to generate some Master Yoda samples. And that's how I created that JSON lines file. Now, if you've got access to Code Interpreter, this is going to be something that you can do. I am going to provide the JSON lines file. I'm going to provide a JSON lines file in the GitHub repo for this project, so you will have access to that. But what I did was to construct a prompt where I took some of the examples from this Kaggle dataset and provided those to ChatGPT. and asked ChatGPT to generate some questions in a neutral tone or some instructions in a neutral tone, and then some responses to those instructions or questions that were in the speaking style of Master Yoda. It was a pain to do this, and it took a lot of prompt engineering on my side to get ChatGPT to do this in the right way. Now, if I was doing this again from scratch, the way I would do it is to actually use the ChatGPT API rather than use the ChatGPT application. The reason for this is because the API is a little bit more flexible. You can create more elaborate prompts, and you can loop that through to create your JSON lines dataset. If you're using the ChatGPT application, there is a limit on the file sizes that you can create there. So if I was doing this again, and if I was doing this in a professional setting, what I would do is use the ChatGPT API to generate that synthetic data set rather than using the ChatGPT application directly. So that's another tip for you. You can use ChatGPT to generate synthetic data samples for fine-tuning. Now, I will say this, the examples aren't perfect. I've got only 1,000 examples in here because that is all I could manage to generate in the time I had to do this project. So that's where the ChatGPT API is better as well, because you can generate a significantly larger volume of samples. But obviously there's a cost to that as well, and I didn't really want to incur the cost. That's another reason I opted for ChatGPT application rather than the ChatGPT API. And if you scan through some of these samples, you can kind of tell they sound a bit like Yoda, but they are far from perfect. So let's look at the top one, discuss the phenomenon of supernovas. And then it says something like supernovas, spectacular and violent they are. Stars, massive in size, collapsing under gravity. Bright and powerful, light years they span. Elements heavy, they forge. Cosmos, reshaped by these events. So it is not perfect by any means. And you'll see that kind of this comes out in the fine-tuning that I've done on the model, but good enough for this project. All right, so we have covered prompt templates and we've covered how the data was generated. Let's look at the remainder of the script in terms of the mechanics. So remember, this is the fine-tuning script. So you can just run this directly to fine-tune a model on gradient. So I'm not going to talk through the details of every function of the script because I think that will be boring, and you are free to examine the script for yourself. It will be linked in the GitHub repository, which will be in the description to this video. What I'm going to do is just talk you through the overall mechanics of the script. So I've talked about reading the samples in now already, and I've talked about, how they need to be broken up into batches of maximum 100. The other thing here with this script is there's a lot of stuff here that is to do with kind of saving states and loading states. And the reason is because I quickly gathered when I started doing this exercise that sometimes when you fine tune on gradient, there can be some internal server errors or something that kicks you off the server for one reason or another. And what you don't want to happen is you don't want to have to start fine tuning your model from scratch. You don't want to have to start again from the beginning. So what I've done is I have built into this script the ability to save this state. So it saves the batch number that you're fine-tuning at, the model, because what's really good about gradient is even if your fine-tuning job has stopped, your model is saved on the platform. So you can always go back to that point and fine-tune from the point that it was stopped. So that's really fantastic about gradient. So it saves all of those details. It saves everything that is needed to resume the fine-tuning or retry the fine-tuning job, even if you've been kicked off the internal, or if there's an internal server error or something along those lines. And I've set this so that it retries 3 times for every batch. So if the error occurs in a single batch, it will retry it 3 times. So it'll retry to recontact the gradient server 3 times. And if it fails after 3 times, then you do have to start again. However, you can change that. So that's what this parameter is here, the max retries. That just tells this script how many times it should retry if in the event of an error when you're fine-tuning the model. So that is all built into this kind of elaborate function here under def main. It's worth talking about the fine-tuning itself. So the fine-tuning is vanilla. It's just running one epoch of fine-tuning. So one epoch is just running it over one batch of data that you provide. And I'll show you where that comes in. So if you look, Yeah, it's just literally this dot fine tune, and you're running it over one batch or one sample. So when you can, what is good about that is you can kind of flexibly create it to run over batches or create it to run over the whole data set. If your data set is greater than 100, then you will have to do it over batches. But the point I'm making here is that Gradient provides you with this API that is quite flexible for you to run your fine-tuning job of your data in the way you want. So I was able to create this loop to run the fine-tuning job over batches. So in my case, because I've got 1,000 examples, it's batches of 10. And then once it gets to the end of those 10 batches, that is one epoch. And then it goes again if I've set another epoch, and it'll run over those batches of 10 again. So you can be flexible with how you run that fine-tuning. And it's quite a simple and intuitive API to work out. They do also have a Python repository on GitHub that you can have a look at, and you can work out how to use the various APIs and the parameters available to you. And that is really it in terms of the mechanics of the fine-tuning. You should be able to work out what's happening from the script. And as I said, I'll provide a link to that in the description for this video. Next, I think it is important to talk about the techniques used for fine-tuning on the Gradient platform, because then we can talk about parameters and how those affect your fine-tuning, and some tips and tricks to set those parameters so that you're fine-tuning models in the right way for your task. Let's talk a little bit about the technique used on Gradient for fine-tuning. Now, I showed you earlier in this video that I didn't spend a lot of money fine-tuning models on Gradient. And okay, I didn't use a massive data set, only 1,000 examples, but I am fine-tuning against a 13 billion parameter model. And also I made a lot of attempts. There was a lot of trial and error in what I was doing. So you might wonder, why was it so cheap? That is literally just $10 to be able to fine-tune and play around with a large language model over the last couple of days. The reason is Gradient actually makes use of parameter efficient fine-tuning techniques, specifically LoRA, which stands for low rank adaptations for large language models. I'm not going to go into too much detail about how LoRA works here, because it is quite involved and there's a lot of mathematics there. But at a high level, you can think of LoRA as a way of creating smaller dimensional layers across your large language model. And when you're fine-tuning a large language model with LoRA, instead of training the entire model, instead of fine-tuning across the entire model, you fine-tune across these lower dimensional layers that are derived from the large language model. And that makes it more efficient, it makes it faster to fine-tune, and it makes it cheaper. So the really good thing about LoRA is that creating these low dimensional layers or lower dimensional layers of your large language model doesn't strongly impact the performance of the model. So it turns out you can just train these low dimensional layers and you'll still get a decent performance out of your large language model. So LoRA does have some parameters, and the main one that's actually exposed in the Gradient platform is the rank. So it's worth talking a little bit about how the rank impacts the performance of your model. The rank has a direct impact on the size of the LoRA layers that you're fine-tuning. So let's just take a step back just to make sure we're on the same page here. Remember that I said that LoRA creates low dimensional representations of your large language model layers. And instead of fine-tuning across the entire large language model, we just fine-tune across these low dimensional layers, these LoRA layers. Actually, the technical term for these LoRA layers is the adapters. So that's why when you use Gradient, you'll notice that they don't call the models on their models, they call them adapters. So that's the technical term for these LoRA layers, the adapters that you're fine-tuning on. The rank parameter directly correlates with the size of these adapters or the size of these layers. So Gradient allows you to adjust this rank parameter, and it's exposed in the Python API. As a rule of thumb, the higher the rank, the larger the LoRA layers that you are training. And that means the more parameters that you have access to once you're fine-tuning. So what tends to happen is that if you are performing a more complex and ambiguous task, if you're fine-tuning your model for a more complex and ambiguous task, you will use a higher rank for your LoRA fine-tuning. Whereas if you're fine-tuning for a simpler task, you'll use a lower rank. So I can imagine something along the lines of creative arts or creating rap lyrics, for example, writing creative stories or movie scripts would be something that's quite complex and ambiguous to fine-tune a large language model for. And then something on the simpler end would be the classic sentiment analysis that you might have done previously, or you might be familiar with, where you just take some text and you classify it into groups. So this is negative, positive, or neutral sentiment. So you might have seen some of those things previously. All right, so now that we understand LoRA and we've covered the rank parameter, let's step back into the Python code and see what parameters we have set for fine-tuning. Now, there is one correction I'd just like to make, and it is a subtle difference, but important just to avoid confusion. I talked about parameters in the sense of the parameters within the LoRA layers and parameters in the sense of actually setting parameters for fine-tuning. So the latter category is actually referred to as hyperparameters. So these are parameters that are not learned from data. We set them manually. So the rank is an example of this, the number of epochs and the learning rate that you can see highlighted on screen now. So it is an important distinction, and just to clear up any confusion that you may have about that. So when I'm referring to parameters here, I'm talking about hyperparameters. So rank for this task, I've set to 25. So I think there's a range available to you on the gradient platform. I believe it's between 1 and 32, but essentially 32 would be the most complex tasks, and 1 would be the simplest task. So I already talked about the example of sentiment analysis, where you're classifying sentences into sentiment of neutral, positive, or negative. So you can think of review classification, for example. That would be relatively simple. Whereas generating a movie script, something that's elaborate and in the style of someone like Quentin Tarantino, let's say, that would be extremely complex. So for the Yoda task, I've set this around 25 as a rank. And listen, this stuff is very experimental. It is trial and error. These parameters do interact with each other. So there isn't a set formula that I can tell you to set your parameters at. All I will say is it depends on your task, and it depends on the data, and also depends on the model that you are using. The thing to note here is that it is good to understand what these hyperparameters do. So you understand rank, and rank directly impacts the size of your LoRA layers. So you can think of that as impacting the amount of trainable parameters that you have. The number of epochs is another important hyperparameter, and that impacts the number of passes that the fine-tuning process does across your entire data set. So 1 pass means that your fine-tuning process has seen every example once. 2 passes mean that it's gone through every example twice. And then there's the learning rate. So the learning rate might not be intuitive at the start, especially if you haven't studied deep learning or studied large language models from their kind of mathematical foundations. But the learning rate is a parameter, or apologies, is a hyperparameter that dictates how much adjustment we make to those trainable parameters in our LoRA layers. So higher learning rates means that we make larger adjustments to those trainable parameters. So to fully understand this, or to grasp this, you kind of have to take a step back. You have to understand that when we're fine-tuning large language models, we are actually adjusting those trainable parameters within the model based on the data that we're feeding to the model during the fine-tuning process. So we're actually making changes to the model. We can dictate the size of those changes by adjusting the learning rate. And what this does is, a larger learning rate makes much more aggressive changes. And, that could actually disrupt the entire model. If that learning rate is too large, you can break your model. You can cause the model to forget things that it's already learned. And the outcome can be quite unpredictable. Whereas, making smaller changes, you're being more risk averse, but you can also fail to converge. So the model can fail to pick up patterns because those changes are too small. And it also means that you might have to train the model over a longer period of time. So you might need more epochs, you might need more passes through your training data set. The point I'm making is all of these parameters interact with each other. And that is what makes training or fine-tuning a model quite experimental. Hopefully that makes sense for the fine-tuning script. For the chat script, I'm not going to go through the chat script in detail because it is quite involved. There is a lot going on here because Gradient does provide an inference endpoint for Llama Index, so you can connect to your models through Llama Index through the Gradient API. But I've done a lot of customization in this chat script, and it would take quite a long time to explain everything that's going on in the chat script. So I'm not going to go into it in detail. The important thing to note in this chat script is that because we're running inference on these large language models, remember what I talked about prompt templates? These are actually built into the chat script. So you can see I have the prompt template constructed here. So this is, there's 2 experiments I've conducted, and we're going to get into that as we start testing these models. So I'll come back to these prompt templates to give you a better explanation of what's happening there. But that's an important thing to note. Other than that, the chat script is, I would say, although there's a lot of functions there, it is fairly straightforward, and it should be something that if you spend a bit of time looking at, you should be able to interpret. Okay. So that is it in terms of looking at code. Now let's actually start playing around with some of these models and see how they perform in generating Yoda text. So let us start playing around with some of these large language models in the gradient testing environment. So there's 2 in particular we're going to play around with. So the first one is the baseline News Hermes model. And this is the model available as is on the Gradient platform. It is an open source model, but Gradient have integrated it into the fine-tuning and inference platform. So we're going to play around with it in the test environment. The second model we'll play around with is the model that I have fine-tuned. So it's the news model I fine-tuned on the Yoda text that I was showing you earlier in the video. Okay, so we want to get an understanding of how the baseline model performs on a task. So what I've done is I have come up with a query that I know doesn't exist in the training data for this News Hermes 2 baseline model. So it's to do with the AI Safety Summit that happened towards the end of last year. So that's not in the training data. So let's ask a question to the news model and see what it comes out with. Now, before I ask this question, I already know what kind of response I'm expecting. I'm expecting it to hallucinate because it's not in the training data, but I'm also expecting that the model does return some response in a fairly neutral tone, maybe quite boring, but it shouldn't sound like Yoda. Great, so let's do that. So hopefully you can see the question on screen now, and it's just tell me about the venue for the 2023 AI Safety Summit. And let's put this into the model and see what it comes out with. So it does take some time to generate. And as expected, the model is hallucinating because the actual venue for the AI the actual venue for the AI Safety Summit was in the UK. So that is not correct. So what it said is it's hallucinated quite a lot there. It said that the 2023 AI Safety Summit will be held at the Hilton San Francisco Union Square in San Francisco, California. So that's not correct. But it has returned some response there, and it doesn't sound anything like Yoda, which is what we expect. Okay, so let's do this same task, but let's switch to the fine-tuned Yoda version of the model. So I have that available here, and this is the model I trained earlier, fine-tuned on Yoda. So what's great is I can switch between these models quite seamlessly, and I hope that you can see all of that on screen. So I'm going to paste that question in and this time ask the Yoda model. And what I'm expecting here, obviously, is that it generates something that sounds more like Yoda. It will still be a hallucination, but it should generate something that sounds more like Yoda. So it's taking its time to generate the response here. And already it's seeming like it is a bit more Yodic, let's say. Let's just wait for it to finish generating, and I'll read it out. I'm not going to do a Yoda impression, unfortunately, but I will read it out. So it says, the 2023 AI Summit, a gathering of experts to ensure responsible development. The venue, a state-of-the-art conference center equipped for discussions of vital importance. The future in our hands, guided by knowledge and cooperation. So it does sound closer to Yoda than the baseline model. However, you may notice that it isn't quite there yet. And here's a big tip for you when it comes to fine-tuning models, especially when you're fine-tuning the smaller models. So when I say smaller models, I'm talking about the smaller large language models, the ones that are kind of in the lower billions. So like the 7 billion models, the 13 billion models. You are going to have to do prompt engineering in combination with your fine-tuning. And I found that this is how you get the best out of the model. So it is clear that the model has picked up some patterns. It's trying to phrase this in the Yoda way, but it does need some additional help. So what we're going to do now is we're going to pose this question again, but we're going to pose it with a little bit of prompt engineering, and we'll do it for the baseline model and the Yoda fine-tune model to see what the responses yield. So let's step back. Let's look at the baseline model. So that's the News Hermes 2. And I have prepared a prompt engineered, some basic prompt engineering for this query. So all I've done is said, you are Yoda from Star Wars. You must craft a response to the following query in a typical Yoda fashion. Tell me about the venue for the 2023 AI Summit. So this is on the baseline. So let's just get a measure of what the baseline can do. So this is with no fine-tuning. There's no fine-tuning done to this model. The model is just operating as is. And it does seem quite well. So it says, gathering of minds, seeking to ensure AI safety, they shall. In a serene forest setting, the summit shall take place. Away from the bustling city, a tranquil sanctuary for thoughtful discourse, it shall be. With nature's beauty as a backdrop, the summit shall inspire wisdom and collaboration. Okay, so that's already sounding a lot better. That sounds better to me than the response from the fine-tuning alone, and definitely better than the response from the model with no prompt engineering, just as is. Right, so let's see what happens when we combine the fine-tuning with the Yoda fine-tuned. We combine the fine-tuning with the behavioral prompting. So let's try that. So again, it's the same kind of behavior prompt. You are Yoda from Star Wars. But on the Yoda fine-tuned model, let's see what kind of response we can get back. So we get a response back, and it does sound very Yodic, in my opinion, qualitatively. So we've got AI Safety Summit 2023 venue. What is it like? Know you must. Wisdom, share and learn we shall. The force, strong in gathering it is. Peace and knowledge together they bring. The future in our hands it is. So quite cryptic there, and it does sound quite Yodic. And you can see that the combination of the prompt engineering and also the behavioral prompting, I guess, and also the fine-tuning has returned something that does sound quite Yodic. Okay, so we're missing the hmms of Yoda, and that's because I can tell you that that wasn't in the training data that I provided to the model. So that's why you won't see that stuff in there. But yeah, it seems like the combination of both is really getting us in the direction that we want, or at least it feels like it qualitatively. Okay, so this is obviously just on the base models. There is no RAG here. So we've done one test on the base model, and we've done another test on the fine-tuned model. We've done it with behavioral prompting and without behavioral prompting, and we've seen that the combination of fine-tuning and behavioral prompting works well. But the key thing here is, how does that translate over to RAG? How does that translate over when we're actually retrieving a context? So some of the results there may surprise you, and we'll move on to that in the next section. Right. So we have tested the baseline model and we've tested the fine-tune model without RAG. Now we can step back into our Python script and actually see how those models perform with RAG. And as I said, some of the insights here might surprise you. So getting the models up and running is quite easy. All you need to do is run the command chainlit, run chat.py. And then if you put this W by the side, what happens is the model actually updates, or the chat interface that we're going to use, not the model, apologies, the chat interface we're going to use in Chainlit updates in real time. And the reason we want to update that in real time is because we have these different prompt templates here. So I said I would talk through these prompt templates really quickly, and I'll do that now. So what we have is this prompt template actually just follows the standard prompt template that we have seen that I introduced before. And that's the one suggested by the News Hermes researchers and the one suggested by Gradient, where you have instruction and a response. But remember, there is also the alternative template where you can have a query, where you can have an input with some context. And that's where our RAG context is going to come in. And I've constructed this script such that the context or the prompt is outputted here in the command terminal. So I will show you what that looks like. But essentially, this is just the prompt template. And then there's the engineering or the behavioral prompting that we've applied to make the model sound like Yoda. So that's one prompt. And the other prompt is just your standard prompt template with no behavioral engineering. So what this means is when I'm running this in Chainlit, so once the Chainlit application pops up and I'm running this, I do not need to put this at the beginning of the query because it's already implemented in the template. So we'll do both. We'll start off running without the prompt template. And so we'll start off running without the behavioral engineering as we did before, and we'll see how the Yoda fine-tuned model responds, and we'll see how the baseline responds, and then we'll see what happens once you put the prompt template with the behavioral prompting in there as well. Okay, so let's get running with that. So it says true right now. What we want is false. We don't want any of that prompt engineering in there. So that will just use the standard template. And then let's just hit save on that. And then we can run it. So that's just taking some time to bring up the Chainlit application. There we go. So it's setting the token and again connecting to the local host, and the application has been brought up in a separate window. So what I'm going to do is I'm going to drag that window in so you can see it. Here we go. So here's our Chainlit application. So this is about the 2023 AI Summit. So here's the page for the summit. Here's the Wikipedia page. And I'm going to index this. And this is quite simply done by going to the menu panel here. And we're going to start off with the baseline model. So, and then we can index that page. So we'll hit confirm there. And I'll show you what that is doing in the background. So what that's actually doing is we're actually indexing that Wikipedia page. So you can see it's downloading, indexing. And I think that should be complete. So if I switch back, yep. So we can see the Wikipedia page has been successfully indexed, and we also have the model ID, and we are using the base model. Great. Okay. So we want to ask that same query, and it's about the venue for the 2023 AI Safety Summit. So let's ask, tell me about the venue for the 2023 AI Safety Summit. Remember, this is just the base model as is. There's no fine tuning on this model. Let's see what type of response we get. And remember, this is now has the 2023 AI Summit Wikipedia page indexed. What I'm expecting to see is a vanilla neutral response that isn't in the style of Yoda with the correct, that is actually factually correct. So let's see what we return. It does take a little time to generate, because remember, we're connecting to that external server. Great. So the response is a lot different to what we saw on the baseline without the RAG. So it's actually telling us factually correct that this summit was held in Bletchley Park, Milton Keynes, United Kingdom. Told us the date when it was held as well. So it says it was the first ever global summit on artificial intelligence. The venue for was Bletchley Park, a World War II code-breaking facility established by the British government on the site of Victoria Manor in Milton Keynes. The summit was attended by notable attendees such as Rishi Sunak, Prime Minister of the United Kingdom, and it's got a lot of extra information in there. But it seems like the retrieval aspect has worked with the baseline model. That's good. I want to show you exactly what's that's doing in the background, so you can see the structure of the prompt here. So I'm going to extend this. Right. So what you can see is, I'll just scroll up. Right, here we go. So you can see the instruction here. Tell me about the venue for the 2023 AI Safety Summit. So you'll recognize that as the prompt we inputted. And then here's the retrieved context. So this is actually retrieved from the Wikipedia article that we've indexed. Safety regulation. So it says Bletchley Park, Milton Keynes, and we can see that we've successfully pulled that in. It talks about the background here, Prime Minister of the UK. Then it talks about Bletchley Park being a code-breaking facility. So there's some retrieve context here, and we've managed to generate something from that retrieve context. And then there's our response. So it follows that prompt template that I was showing you earlier, just to give you more comfort with that. You can see here, you've got the instruction. Let's just scroll up, show you that one once again. Let's just slow down. Yep, so you can see the instruction here, and that aligns with the instruction in our prompt template. And then you've got the input with all of that context, and you can see the input there. And then finally, the response, which is generated by the language model. And you can see we've left a space for the response to be generated, and it has successfully done that. Great. Okay. So I guess the natural question is, right, that's all good. That's the baseline. What does it look like? What does the fine-tuned version look like? So let's have a look at that. Let's see what the fine-tuned version looks like. So we'll step back into the Chainlit application. We'll go into the settings, and we will select the Yoda version, and that will reindex the page and select the Yoda version for us. So once that's ready, we'll see that pop up. Great. So now we're using the Yoda model, and you can see, just to show you, it's a different adapter. So where we used the base model before, now we are using the fine-tuned adapter, and I will ask the same question. We can compare the results qualitatively. Okay, so we have a response. It says the AI Safety Summit, an international conference on safety and regulation, was held at Bletchley Park, Milton Keynes, United Kingdom. It was the first global summit on AI and is planned to become a recurring event. Noted attendees included Rishi Sunak, Kamala Harris, Charles III, and Elon Musk. Okay, so factually, it has correctly identified the venue. The style is definitely more Yoda-like, with those kind of shorter sentences and commas than the previous response from the baseline model. However, there's two things. It's not really close to Yoda. Actually, it seems like the Yoda bit has been lost here. Even though it is closer than the previous response, it seems like it's been lost. And the second thing is, it has correctly identified Milton Keynes as a venue, but it hasn't given us much more information about the venue. I guess you could argue that the query itself was vague, so maybe we can give that a pass. But for certain, the Yoda style isn't there as we would expect it to, and it's not even there as much as it was without the RAG bit, so without the context bit. This is where it gets really interesting, because what might not be intuitive at first when you start building these is that when you fine-tune a model, and then you're using that fine-tuned model to retrieve context that is in a different tone, that can actually cause the model to be the tone of the model that you fine-tune to be hijacked. So I think that's what's happened here. Because we've retrieved a lot of context from Wikipedia, we're losing the Yoda fine-tuning aspect of this. Now, how can we resolve this? So you might have guessed, and this is the big tip I have, and this is what I've discovered while working with this, is that, a combination of fine-tuning and also some clever prompt engineering can actually help to overcome this issue. So let's explore it. Let's first look at the baseline with the behavioral prompt, and then let's look at the fine-tuned model with the behavioral prompt. So we can do that easily. We just need to step back into the code, and we'll move this down. So stepping back into the code, we will change this to true and hit save. So what I will do is that's going to refresh the chainlit front end. We'll step back and pull that up. So that has now refreshed, and we'll start off with the baseline. And then we're looking for the AI Safety Summit. We'll confirm that, and we'll wait until the page has been indexed. So that's been successfully indexed. And now let's try this. So remember, this is just the baseline model. We're just seeing, just with prompt engineering. So just tuning the behavior to speak like Yoda rather than actually fine tuning. Let's see what happens. Let's see what type of response we get from the model. So we'll just wait for it to generate, and I'll show you what that prompt looks like as well behind the scenes, because you'll see where the fine tuning, you'll see where the behavioral tuning has come in. So here we go. The venue for Summit AI Safety, Bletchley Park, Milton Keynes, United Kingdom. Nod. So there's even some kind of actions in there. A significant place it is. World War II code-breaking facility it was. Victorian manor it stood. Computing history, it played a role. 28 countries it brought together. Elon Musk, Rishi Sunak, Kamala Harris, Charles III, notable attendees they were. Bletchley Declaration they issued. AI safety they discussed. Future Summit, South Korea to host. AI Safety Institute, US government to create. Nods again. So that is pretty good. That sounds quite Yoda-like to me. And there's even some actions in there to mimic Yoda. So let's have a look at what's happening behind the scenes. So if I pull this up, you can see it's the exact same. That was the last one. So let's go down to the next one. So yeah, you can see it's the exact same prompt structure, except now we have this Star Wars bit appended, right? So we can see it says, you must craft a response to the following query in a typical Yoda fashion. And then we get that query in there. Tell me about the venue for the 2023 AI Safety Summit. And then we get our retrieve context, and then what has been generated by the model. Great. Okay, so let's see if a similar performance happens with the Yoda fine-tune model. So all we have to do is step back in here and select the Yoda News Hermes model and hit confirm. That's going to reindex everything. And then let us select that again. And let's hit run. So this will take some time again. Okay, so it has run. So we've got a global summit on AI safety 2023 held in Bletchley Park, United Kingdom. Rishi Sunak host, many nations in attendance, agreement calling for international standards. AI safety, a priority for governments. Future summits planned by South Korea and France. Experts in discussions. For force, for good it can be. So it has tried. And what we've seen is that the combination of the prompt engineering and the retrieval, sorry, apologies, the combination of the prompt engineering and the fine tuning does seem to push it back in the direction of sounding more like Yoda. Actually, the prompt engineering alone, so the behavioral guidance, seemed to produce a much better outcome than the fine tuning. And here's why fine tuning is actually really difficult. It's difficult because you have to have really high quality data. And I think a lot of what's happened here is because the data I used to fine tune this Yoda model wasn't of the highest quality. Didn't include a lot of the actual things that Yoda does, like the ad libs, the movements, and that seemed to already be captured in the model. So fine tuning it might have actually hurt the performance of the model when trying to imitate Yoda. So combining the behavioral prompting and fine tuning seems to have pushed the model back in the direction of sounding more like Yoda. However, it does seem like the behavioral prompting by itself, for this particular question anyway, is sounding better. Let's see for some other questions. So I'm going to try some other questions for the same Wikipedia page. Of course, we can index other Wikipedia pages, but just for now, I'll stick to this page and see what we can get. So I'll start off again with the baseline model, and that's easy enough to change. And remember, this is still with the behavioral prompting. So it's baseline, non-fine-tuned with behavioral prompting. I'll hit confirmed. And once that has been confirmed to have indexed, I'll ask another question. So the question I'm going to ask this time is, what were the main themes discussed at the 2023 AI Safety Summit? Let's see what the response is. So here's the response. Event of great importance was the AI Safety Summit held at Bletchley Park. Many leaders from nations near and far attended. Agenda filled with discussions on regulating powerful AI systems, known as frontier AI. Conference focused on safety, risks, and challenges posed by artificial intelligence. Topics included use of AI in terrorism, criminal activity, and warfare, as well as existential risks to humanity. Summit led to the signing of the Bletchley Declaration, calling for international cooperation to manage these challenges. United States announced new rules requiring AI developers to share safety results with government. Event marks first global summit on AI safety to become recurring event. Though this was quite inconsistent, if I'm honest, right? So what's happened here is we've given it this question with the Yoda prompt for behavior, right? And it's returned something that doesn't really sound like Yoda, and it wasn't anywhere near as good as the response we got from the Yoda behavioral prompted base model. So maybe there's a bit of inconsistency there. Let me try with the Yoda fine-tune model. So we'll wait for that to index. So that has successfully indexed, and I will try that question again, but this time with the fine-tuned model rather than the base model. So we'll wait for that response. And of course, this isn't a comprehensive test at all. You would need much more examples of questions to properly test that this is working. But my hypothesis is that, and I think it's a useful tip, it is that you can steer the behavior back towards the fine-tuning if you also include some behavioral prompt engineering. Yoda, understand the summit's purpose, artificial intelligence, regulation and safety, the need to discuss. Leaders and experts from around the world gathered at Bletchley Park, the challenges and risks of AI they address, cooperation and agreement, the Bletchley Declaration they issue, the frontier of AI regulation and management required, the potential for harm, concerns raised, a recurrent event the summit will be. So in my opinion, that is definitely more Yoda-like than just the baseline model. So it's looking like there is a bit more consistency when we have the prompt, so the behavior prompt, and also the fine-tuning. All right, so if I continue to do examples in this video, I'm going to run out of time, and I won't ever be able to do enough examples to kind of show statistically that it's qualitatively better to it delivers qualitatively better outputs to actually have both the behavioral prompt and the baseline prompt. However, as a tip, and just from my experience of playing around with these models, I can say that I believe if you have the behavioral prompt, the behavioral prompt and the fine-tuning, it works better and delivers more consistent outputs than just having the fine-tuning alone or just having the behavioral prompt alone. And this is especially the case when it comes to these retrieval augmented generation, these RAG use cases. All right, so that's a bonus tip for you. Hopefully that is something that you have learned from watching this. The last thing I want to show you before we move off is I want to show you what happens if we amend the prompt template and we try to ask questions of the model. So I'm going to purposely break it by messing up the prompt template. And this is just to give you a real idea about why the prompt templates are important. So let's purposely break it. I'm going to do something like I'll remove this. Let's remove that, and let's mess this up too. So what I'm doing here is I'm purposely destroying the format of the prompt template just to show you what happens when you do. Okay, so I'm going to hit save on that, and that's going to trigger the refresh of the front end. Apologies, I realize I actually need to step back because I have changed. I don't want to use the prompt engineered one. I want to use the standard ones. Okay, so let's just go with the baseline one. And let's do the AI Safety Summit thing again. Now that that's indexed, let's try this one and let's see what happens. So already you can see it's actually taking a lot longer to generate an answer, and that's usually not a good sign. It usually means that the model is struggling. And here we go. So we have just returned sources. And that's what happens when you mess up the prompt template. So if you're finding you're working with these models, the open source ones, and you can't get them to generate anything coherent, it's probably because you have not been adhering to the prompt templates. So do that at your own peril. Make sure that you do adhere to the prompt templates. If you're using an open source model of a platform, whether it's a platform like Gradient, or if you are using something like Hugging Face and the prompt template is not available to you, you might wish to pick a different model because you're going to run into issues. Okay, so that is pretty much it. We've covered a lot. We have covered the Gradient platform. We've also covered the use of fine-tuning. We've covered parameter efficient fine-tuning, which was the LoRA, the low rank adaptations. And we've looked at the hyperparameters and how they impact the performance of your fine-tuning. We've also tested models. We've tested the baseline model against the fine-tuned model without RAG, and then we've done some RAG testing too. We've looked at some of the Python scripts that I've written to make this all possible. And we've talked about prompt templates and how they impact the way that models generate things. So hopefully you have a much better appreciation for how these large language models work behind the scenes. You know, I think because we use ChatGPT, sometimes we take these things for granted, but there is a lot of engineering behind the scenes to get these models to work in the way that is useful to us. And this application, you know, building a Yoda RAG chatbot on the surface seems quite simple, and probably is simple to implement if you're just using the ChatGPT API or the OpenAI API. But there's a lot of engineering behind the scenes that makes it simple. And, you know, that's a huge model. So I hope you've learned a lot from this demo. If you like this, you can get onto Gradient and get your $5 credit, and you can use this project and try to tune your own model if you want, using the scripts I've got. Thanks for watching. If you liked this content and you found it useful, please feel free to comment, like the video, share, and subscribe to the channel. Thanks for tuning in, and I look forward to seeing you on the next video.